Hi, today I'm going to teach you how to answer this statistical question on the ACL experiment. The first thing, I'll give you a general explanation of the question. So, it's a new treatment for the ACL surgery. So they have a new experiment and they want to test if it decreases the recovery time or not. So in this study they have 210 participants or patients, and so that's what the experiment is going to consist of, 210, and it's going to be randomly assigned between the two groups, and the two groups are going to be new treatment or old treatment. So the first question is, based on the design of the study, would a statistically significant result allow the medical center to conclude that the new procedure causes a decrease in recovery time compared to the standard procedure? The design of the study is randomly assigned. That means that they're randomly assigned between the two groups, and we want to know if there's a difference between the two groups, between the new treatment and old treatment. And so that means that if it's randomly assigned, then we know that it's going to be random. There's not going to be any inconsistencies in. And the next thing is that the N is 210, which is the number of patients. That's between both groups, but if we took half of that, it would be 105, and the rule of thumb has to be over 30. So we know both the groups are definitely over 30, and the reason for that we want to know that is because now we know that we can model them along the normal curve. Therefore, that both groups, if we can see a difference and it's statistically significant, then we can conclude that there is a decrease in recovery time. So we know that because of this. And the other condition is that if it's more than 10% of the population, and we definitely know that 210 is less than 10% of the population of all the people getting surgery within, I don't know if it's in America or somewhere. So we know the answer to this question is yes, we can conclude that. Okay, the next part B is, do the data provide convincing statistical evidence that those who receive the new procedure will have less recovery time from the surgery on average than those who receive the standard procedure for patients similar to those in the study? So, to answer this, we will have to see if there is statistical evidence. First step is to state a hypothesis. We know the conditions are true for this, so we will read an accurate response. And the test we want to use is called the t-test. Hopefully it's not too wonky and you can read that, but okay, so it's the t-test, and the hypothesis for this, to know if it's statistically significant, we can use this hypothesis statement, which is, I'll use, of the first group is equal to the mean of the second group. And the alternate is that the mean is larger than the second group. Now this is only for above the normal curve, not on both sides, because it's only interested if it decreases, not if it increases. So there we go. Okay, so now we can find, so we have, it gives us the table, okay, as you can see, and we have the standard deviation of 34 and 29. We want to get the standard error. To get the standard error, we can do it over here. Okay, I've just written down the standard error, which is 4.350. So that's the individual standard deviation squared divided by the n of the first group plus the standard deviation of the second group squared divided by the n of the second group. All of that square rooted, and that gives us 4.350. So that's going to be what we divide to get our distribution value, or the value on the t distribution, and we're going to get, we'll write it here, t equals, it's going to be the, so as we said in the hypothesis, it's the mean 1 and the mean 2. It's going to be equal to each other, and that means that they're going to be equal to, that both of them minus is going to be equal to 0. So we'll minus them. So we're going to get the value of our first one, which is 217. That's the first group of the old treatment. That's the old treatment time minus new treatment, 186, I believe. I think so. And divide that by the standard error, 4.350. There we go. Okay. The answer to the t value is going to be so the answer to the t value of the t value is going to be I think it's called t value, the t distribution, like the z value but for the t distribution, is going to be 217 minus 186 divided by 4 point, clearly a point right there, this is our standard error, divided by 4.350, and that's going to give us 7.126. Okay, and now if we look up that value on the probability distribution of the t distribution, we're going to get, forgot to mention, so if we look up that value in the t distribution using the degrees of freedom, which is going to be the n minus 1, and we use the n of the lowest, the group with the lowest amount of n, the lowest n, or the lowest amount of people is 100, and you minus that, and you get 99, and that's going to be the t distribution you look at. So it's going to be 99, the value of the degrees of freedom, and the probability distribution you're going to get using the t when t equals 7.126 on the above the distribution, the amount of probability above it, 7.126 is going to be so tiny, it's going to be 8.469 times 10 to the power of negative 11. That's 0 with 11 zeros, so 0.11 zeros, and then 1. So practically, it's showing that this shows this is smaller than 0.05, which is going to be our significant our significance, because we're going to have alpha equal to 0.05, meaning that we can reject H naught in favor of H alt A, meaning that there is a difference. So this is showing clear evidence that there's a decrease in time. Thank you for watching. I hope that's all correct. And thank you.